Hello friends, good evening, how are you? So we are solving this problem, delete duplicate folders in system. So let's read the question first. So we will read everything and we will visualize everything. Then we will also write the code together. So I would highly suggest if you guys can take your pen and paper and understand each and every step, not only the steps but also in the terms of code, that how do we write all those particular concepts, whatever we will discuss here. So what is happening is, due to a bug, there are many duplicate folders in a file system. You can consider like this. So you are given a 2D array paths, where path I is an array representing an absolute path to the ith folder in the file system. For example, you can see here, suppose these are our path as per given in the question. Okay, so we will look forward. So you can see here, these are the 2D array, right? Lot of 2D arrays are there, and in these 2D arrays what we have is, we have, for example, here this is A only, so this is representing only this folder. If it is written A, that means it is representing only this folder. If it is written C like this, C is another array, this is representing just this folder C. So if there is an AV, right, so that means it is representing a folder like this, A/B. Why? See here, there is a folder A, inside A there is a B folder, so it is represented by this this denotation. Okay, similarly see here CB, so it is representing to this guy because it is inside C, so that is why we are calling it CB. So 2D array has like this. Okay, let me bring this bit downwards. Okay, similarly now come to ABX. What it is representing? It is representing something inside A there is a folder B, and inside B there is a folder X, so it is basically representing ABX. So where is that ABX? So if we start from here, A, there is a B, and inside B also there is a X. So these three values are representing this folder, X folder, right? ABX. Similarly we have ABXY, so this is representing to A, B, then X, then Y, so it is representing to Y. So if we want to represent this Y folder, it would be something like AVXY. So absolute path would be there, A to B, inside B we have X, and then inside X we have Y, right? Similarly we have W, so this W is directly coming, right? So we have just put the root as the slash. Okay, we can consider, because we need at least something to consider as root, right? Then we have like WY, so WY means something inside W, right? So this is how we are interpreting these folders. Now come to the question, that what they are asking is, we have to delete those folders which are duplicate. Okay, what does it mean is, two folders not necessarily on the same level. So if two folders which not necessarily on the same level, there could be third level and second level also. They are considered identical if they contain the same non-empty set of the identical subfolders and underlying subfolder structure. Basically what does it mean is, like let's say there is A and B folder, so they would be considered identical if they have inside, let's say, X and Y folder, and similarly B also have X and Y folder, and similarly if X and Y also have subfolders inside them, all of them should be same if we compare folders as well as subfolders. So that is called the identical. Then A and B called be identical. So the folders do not need to be at the root level to be identical, it can be anywhere. If two or more folders are identical, then what we have to do is, first of all we have to identify those identical folders, then we have to mark the folders as well as all their subfolders. Okay, so for example we can take this example here. Okay, so you can see here what is happening. If you see here, this Y, okay, so this Y and this Y, so W has this Y, right, only this Y, and similarly X also has only this Y. So we can say here that X and Y and also W and Y, both of them are identical, because X has one folder, that is Y. Similarly, W also has one folder, that is Y. So we have to mark this as well as this guy as the true for the deletion. Similarly, X and Y also should be marked as for the deletion. We will take for further more examples. Let's say see here A and C, right? So A and C, both of them has B, right? So it also looks like identical, but no, because here if we check here, B has further values, like B has further one more folder called X, and X also has Y, but here it has only B. So A and C are not identical. A and C are not identical, but you can see W and X are identical. Y is also identical with this guy, because these guys are coming like at the same number of identical folders. So that every folders are denoted by their absolute path, right? So what is the absolute path of this W? This is directly coming, right? So W have only absolute path W, and this Y would be have W/Y. Now come to this guy X. So what is the absolute path of X? Absolute path of X is A/B/X. This is the absolute path of it, right? So if we look here, we said that X and W are the identical. So if we replace these X and W with their absolute path, what we can say here is, what is the path of W? It is /W, right? So we can say this is W. And for Y, what would be the value? For Y, it would be /W, W/Y, right? So both of them, this is the parent folder and this is the child folder of it, subfolder you can say, right? And similarly X and Y. So what would be the absolute path of X? Absolute path of X would be A/B/X, right? A/B/X. And what is there in Y? So how would we represent Y? Y would be represented A/B/X/ finally Y. So now you guys can say that this guy W and this guy both are identical, and their subfolders is this guy WY, and here ABXY. These guys are the subfolders who are also the identical, right? Because this is only Y and this also at the end only Y, and these are just the path of them. So now what we will do is, we have to mark this guy, right? First of all, we will mark this guy as free, right? So free means we can mark it true, right? And it's a subfolder also, this guy also would become true, right? So this guy also would be true. Similarly here this guy ABX, this guy also would become true, and its subfolder also would be true, correct? So all these things, once we have done the true, what does it mean? Why do we doing true and all? So true means these are the guys which should be deleted, right? So if we do that operation, it would be looking like this, right? If we delete this guy and both of them, so this will be gone, this would be deleted, because this X is taken as the marked true, so this would be true. So this guy would be deleted like this. Similarly this W and Y, both of them were deleted like this. So finally our graph would be, if we represent it still in the form of graph, it should look like this, right? So what would be the answer in this case? How many folders we have? We have total 4 folders that we can still see, right? So how do we do that? So A is one folder, right? And then we have AB is another folder like this. Similarly we have C is one folder, so we will write it C like this, and CV is the another folder. So this should be our answer after deleting the identical folders. See here, this is the list that we are expecting in the answer. So now you should be very clear that what we have to do, right? Now the next thing is how to do that. Okay, so That is the important thing. So we will build the intuition. I will not go directly that I have seen somewhere solution, so I will directly jumping into that solution. No, we will build the intuition together, that what we should do, and then how we would be proceeding here. Okay, so now you guys would be observing here that when did we found that this is a duplicate, right? We were going from here, right? We came here at B, similarly we came here X, then Y. So somewhere we got Y. Now when we would be traversing here, we found C, then B, then nothing, then we came here W, then Y, right? So you can observe here that whoever is becoming identical, their leaf nodes are somewhere reaching at the position from where we could get some intuition, right? That if let's say this leaf nodes are same like Y and Y, if leaf nodes are same, that means their parents, whoever is their folder parent, that guy would be definitely gonna identical. Just like we got this W and this X as an identical because they has the same child. But we have to go in bottom up approach here. We cannot go like checking here. The right time complexity would be very high if we go and check everywhere. So what we will do is we have got one intuition here that we might check in the bottom up approach, that somehow if we are calling some function which is bringing us to down and then it is closing when it is a leaf node. Now if let's say I write a recursion in such a way that whoever is coming as leaf node, if I am storing it somewhere, right? And if this similar leaf node is again appearing anywhere, if I can check that hey, is this always visited, right? For example, if store this guy, if I store, let's say I am calling this function here, so I am storing this y, then xy, then bxy, then abxy, right? If I can store, let's say in hash map, then again when I would be coming to these locations, I can easily check that hey, this y is already appeared. I can store it in form of a key, right? So if a y is already appeared, then I will get an intuition. That means we would have something similar as a subfolder of some parent folder, right? So in this way, we can store in a hash map the key as the string like y in this case and the corresponding node. So let's say we can make a hash map which store the key and value, where key would be the string of that folder. Okay, for example like y, and it would be storing this node, right? So we can store the node of this address, suppose. Okay, similarly, so if we stored, let's say we called a function, if we stored like this, we stored y with a node y. Okay, similarly we would have stored xy with a node of xy, right? And similarly so on. So in this way what will happen, we are keep on storing, right? So these guys are coming first time, but when we will coming at here, when our bottom call would be here, we will check that okay, key is y, then we will check that hey, is there key already there in the hash map, right? So if we see here, we have found that there is an already a hash map key which has y. So then we will check that what is the node here. So for this node we can make it true, right? And at whoever node we encountered this thing, let's say for this node it would be w, from w we reach at y, right? So we will make this guy as true for the deletion, this guy also true, and the node which we have stored in the hash map, right, this also we can directly fetch from the hash map and make this guy also true, right? So in this way we can write a function which would be doing this. Now we will try to, now some intention would be, some intuition would have been cleared so far, that what we gonna do now. So first of all we will because just this is a representation, we want to store all these values first of all in a data structure, right? Because we are given only these 2D paths, right? This representation is only for the understanding purpose, but we are given only this input paths equal to 2D array. So first of all is how to store all these information. Okay, so you guys know that when we store these string kind of stuff, tries are very nice in the storing them. Okay, so we can use try to store them. Okay, so I'll show you that how the try would be storing all these values. So first of all, I will show you that how the try class, we will create a class called try. I will show you in the code. So far we are clear, right? So we can at least go for the try part of it. Okay, so let's say I'm creating a class here. I'm creating a class called try. So this class try would be have 2-3 things. Let's say we have a string ID, like we have ABC, right? So we can take this ID, and then also we can have a boolean array. So boolean variable we will call free, right? So initially we will keep it false, right? By default it would be false. Then we can have this thing a hash map, and this hash map would be made of what? Let's say we are calling it hash map of type string, and its value it would be storing the try itself. This is how try works, right? So we can write it together. Let's say I'm calling hash map hm. Okay, now we will write the constructor of this try, right? So let's say we have two constructors for it. One is the empty constructor. By default we don't know where we need it, so we can write it, and one more constructor we can write like this, public try, and we will pass the whatever would be the ID of it. So let's say string ID, right? So what we will do is we will be make this dot ID equal to ID, and we will create this hm equal to new hash map like this. Okay, so let's keep this boolean. By default it would be stay free, so even if I remove this, that also should be fine, right? So we created two constructor for this try class. Now in this try class itself we will write a method called insert, right? Because we have to insert the things. So before going to more of this, let me first explain that how this try would be look like and how we gonna store the things. Then I would be storing these values like this. So this is an object of try class, right? So you can see here the one which we just discussed. See here, this is the try class. It has a string ID, then has boolean variable free, and then this hash map of string and type, right? So this is how we are storing. See here, ACW is coming at very first layer, right? Because this will come in the first hash map itself, and ID of it is by default, as we have taken empty, so that is why the very first one is by default empty. Okay, so then we have these values, corresponding values, like A is connected to B, and C is connected to B, and W is connected to Y. Then they are further connected to X, Y, and at the end all of them are connected to one empty object, right? Because that is the end of it, right? So this is how try works. Now why do we want to store in try? Because the one approach which we discussed, that we will write a recursive approach, that whenever a repeating value occurs, to do that operations we need this try kind of things. Though we can write a corresponding tree also, and again a hash map would be definitely required. So n-ary tree kind of thing would be here, but we are going for the try kind of paradigm. Okay, so we'll write the try code first and how to insert these values, then we will walk through it. See here, this is our class try, and I'm calling this map equal to links. Okay, so links equal to new hash map, which is of string and try, and by default we are giving this ID equal to just null string, and boolean mark, I'm calling it a better name, mark equal to initially false. So I have created two constructors. One is empty and another is one which is assigning the ID value. Okay, now this is our insert method. What this insert method is doing is we are taking the whatever node we have, right? See here, this is the first hash map of our node, right? So what we are doing here is we are taking a path of strings, right? We are taking a list of strings, and if we want to if we want to insert that path of the strings, what we will do is we are using a for loop, and we are taking every string inside this path. So what we are doing here, this is links is hash map, that one we created. So what we are doing, we are node dot links put if absent. So if in the hash map, if s is not there, we are creating this s as the key, just like this. We need the key, and then we are creating a corresponding try node just using this constructor, because our hash map is of try, string as the key and try as the value. So we are creating that, right? And then we are moving ahead to the next node, just like you can visualize here, that first we would have created this hash map, and then if we are going to this a, that means we are going to the hash map of this a value. So if we are coming to what would be the next value, next will be this guy b, because this is a try node of this a is the key, then try node of it would be this guy b, right? So same way we are doing. So that is why what we are doing here is node equal to next node is equal to node dot link dot get s, so that we will go for the next link. Similarly, we would be keep on inserting for every string we have in the this path. So these two methods, this one method only we have. So we are done with the try class. Now using this, we will go for our solution. So let me see, this is our delete duplicate folder, right? This is our method. So first of all, see what I'm doing. We are given a 2D paths array, right? See here, this is 2D path array. AC, AB, CB, all these are 2D path array, 2D list of lists we are given, right? So same thing what we are doing. First of all, we are inserting all those paths one by one into our try. So here we are inserting everything to this try. Now you can see here one more method called serial. Okay, what this method would be doing? This method would be in the bottom up approach. It will check that if some path is already occurred, let's mark it true. True means this is a duplicate folder, right? So this serial method we will look now. And also there is one more method, to answer method. So once our serial method would be fulfill all the conditions, that what node should be true, what node should be false. Once we are done with that, so then we are calling this method, to answer method. So for the same try which be updated in serial method, for the whoever node is becoming free for the reason of duplicacy, then from there we will extract the answer. Okay, our answer should be list of list. Like in this case, we got the answer was this thing, right? We deleted w and y, and we deleted x and y. So it was only a, b and c, b, a, b and c, b. This was the answer, right? So that we would be calculating after doing that. So let's look for this serial method. What the serial method is doing, our try would be filled with the values, all the values that are given in the 2D array called path, right? We have stored all those values like this, right? Now all of them are there inside the try. Now we will call a serial method. What this serial method would be doing here is basically